So this next video then will cover sections 4.7, 4.8, 4.9, which deals with optimization problems, Newton's method, and then the other part of calculus, antiderivatives and intervals. So first off, in terms of section 4.7, you get in terms of this chart, which is in the book, about how to solve what are called optimization problems. So basically they're going to be word problems. So read the problem, figure out what's going on, draw a picture if it's helpful. Notation, symbols, so x, y, whatever. Okay. Express in terms of only one unknown, and solve it by using a derivative. So let's look at an example of how this works. So for example, farmer has 2,400 feet of fencing, want to put a fence in along the river. We're going to have no fence along the river, so basically we have our river here, and we have some fencing that's going to go like that along the river. We know how much fencing he has. We want to maximize the area, right? So let's call this x, which means this will be x, which means this will be y. Right? And so area of a rectangle is given by x times y. And then the amount of fencing we're using is going to be x plus y plus x. And we know that has to equal 2,400. And so 2x plus y equals 2,400. Right? So we want to maximize this, but this is in two variables, and we only want it to be in one variable. And so we're going to take this equation, and we're going to solve it for y. So if we subtract 2x, we get y equals 2,400 minus 2x. So now we can take this and we can substitute it in here for my x. So now we get that the area is going to be given by x times 2,400 minus 2x. So now I got my area equation in terms of only one unknown. Right? And so the area is going to be 2,400x minus 2x squared. Next thing you want to do is take the derivative. So dA dx is going to be 2,400 minus 4x. And now that we have my derivative, we're going to take our derivative and we're going to set it equal to 0. So that way we know that a min or max occurs when the derivative is equal to 0. So we're going to solve that for x. So we add 4x. We add 4x. So 2,400 equals 4x. And the next step is divide by 4. And x is going to be 600. Right? So we know x is 600, so they want to know the dimensions of the area. And so we got that y was 2,400 minus 2x. So y equals 2,400 minus 2 times 600. And so y will be 1,200. So my dimensions will be 600 by 1,200 for this fencing. Okay. So let's look at another one. So we got 1,200 square centimeters of material. We're going to make a box with a square base and an open top. So basically we got a box with a square base. So this is going to be x by x. And then we're building a box have our box. And the height of this is going to be y. Right? So in terms of material then, well, we got the bottom in terms of the area is going to be x squared. Right? And then we have 1, 2, 3, 4 sides each, which will have an area of x times y. Right? And it says there is no material on the top, so that would represent the amount of material that we're using to build this box. Right? We also want to look in terms of the volume, and the volume of my box will be given by x times y. So my volume is x squared y. Okay? Well, again, I have an equation here, my volume equation, which is in terms of two variables. Okay? And we don't want that because we want to be able to have it in terms of one variable. So we need to get rid of a variable. So let's go up to my area equation and isolate the y. So we got x squared plus 4xy equals 1200. We subtract the x squared. So we get 4xy equals 1200 minus x squared. Right? Next step would be to divide by 4x. So we divide all that by 4x. And so we get y is going to equal 1200 minus x squared over 4x. Right? So now we're going to take this and, again, make a substitution and substitute that in there for the y in my volume equation. So my volume now is going to be x squared times well, let's simplify this a little bit, because I got an x squared out here, I got an x down here. I know that this will go away, and we can just cancel the exponents there. And so we have 1200x minus x cubed over 4. Well, this would be the same thing as saying that this is going to be 1200x over 4 minus x cubed over 4. So this will be 300x minus 1/4 x cubed. Right? So we just did a real bit of rearranging here. Right? So now we have my equation of my volume in terms of one variable. The next step then was to take that equation and set it equal, skipping ahead. So here's my volume equation, and now we want to take our derivative, and so dv dx is going to equal 300 minus 3/4 x squared. Okay. So that's my derivative. Now we take our derivative and we set that equal to 0. So let's take the x squared term over to the other side. So we get 300 equals 3/4 x squared. Going to divide both sides by 3/4. And so this will give us 400 equals x squared, and so x will be the square root of 400, and so x will be 20. So we know x is 20, and so now we can get y, because we said that y was going to be 1200 minus x squared, which is 20, over 4 times x, which is 20. And so we put that in, we get that y is going to be 100. So my dimensions of the box are 20 by 20 by 100. So you have in terms of optimization problem. And so again, basically you find the equation you need in terms of whatever volume area equation, whatever is going on, draw a picture, label everything. Again, we can only solve it if it's in terms of one unknown, so we may have to do some other side algebra to get to that point. Write the equation in terms of that one unknown. Take the derivative. Once we have the derivative, set that equal to 0, and then solve for our unknown. Okay? The next step, section, deals with Newton's method. Again, this goes back to the days of not having a calculator. And so you got in terms of Newton's method for finding the approximate root. So finding the answer. So the method basically is now a calculator exercise. And so the method is this. So the current guesstimate is the previous minus the original, evaluated at that, divided by the derivative at that. But let's look at this in terms of an example as to how this works. So for example, we have x cubed plus 2x minus 4 equals 0. And let's see, all right. Should be x cubed minus, sorry, this should be x squared. Okay. X squared minus 4 equals 0. Okay. And the first look, as they say, is that the number here is going to be 1. Okay. So we have in terms of this one. Okay. So my derivative then of this, right? So the derivative would be 3x squared plus 2x. And actually, let me stop there a second. I need to check